All right, let's go ahead and get started. So a couple things first. Does anybody have any questions about any of the topics we covered last time? Remember, there'll be a quiz on Wednesday, 2 days from now. And the first assignment is also due Wednesday at 11:59 p.m. And make sure you go to office hours and ask questions. There's been some good questions asked on Piazza that I've answered so far. If you have any follow-up questions, let me know. I also uploaded a video that gave an overview of the first programming assignment, kind of walked through what you're expected to do, talked about the skeletons, ran my solution through the JUnit test so you can kind of see what it's supposed to do when it runs correctly. So make sure you take a look at that. It's really not a very hard assignment, but there's work involved, so make sure you start that early. Don't wait till the last minute. And remember, you have to turn it in on time. In the next day or so, I'll post a note with a Google form that you have to fill out so I know where your GitHub or your GitLab repository is, so I'll be able to download your code and review it for you. OK, so let's go ahead and continue discussing about Java. We're going to give an overview of a few other aspects of Java's support for data abstraction and control abstraction. In Java, you can group classes and interfaces into something called packages. And the intent of these packages is basically to cluster together various related abstractions, data abstractions, and so on, so they are easier to follow, easier to understand. This is really purely for humans to consume the structure of the code in a more intuitive way. So for example, if you look at Java itself, you'll find there are various built-in packages like java.lang, java.util, java.io, and so on and so forth. And these contain things that are, for example, strings and integers and threads, very fundamental to the design of Java itself. They're things that are common, excuse me, common abstract data types like vectors, hash maps, array lists, and so on. There's also operations on files. There's, many packages. I think there's something on the order of 100 or so packages that are part of Java that forms the structure, sequence, and organization of the code. And one of the other things that packages do by grouping things into packages, and you have your own packages when you write your own apps, of course, they allow you to be able to manage large projects by avoiding collisions in the namespace. So if you have two classes in your app called stack, then they won't collide because they'll be grouped into packages. So they're organized more effectively and more intuitively. There's something in Java called the garbage collector that's used to automatically reclaim and recycle memory that's not in use by a program. Garbage collection makes it a lot easier to write apps because you don't have to worry about dealing with memory allocation and reclamation, unlike a language like C++ or C, where you have to do that explicitly. And basically what happens under the hood is that the Java virtual machine basically keeps track of whether an object is being used or not. And once something is no longer being used, it's subject to garbage collection, which means that the garbage collector will come along and sweep that memory and make it reusable for something else. And not every object-oriented language supports garbage collection. C++ is probably the most famous exception to this, but garbage collection is essential in Java. Just because something is garbage collected doesn't mean it's always easy to do, and there's all kinds of ways you can get yourself into trouble by not making it clear that garbage is garbage, and we'll talk a little bit about that later as we go on through the course. There's also a number of features in Java that support so-called control abstraction. There's a number of them. They typically involve branching or iteration. Those are the two typical things. There's also something else we'll talk about in a second relating to exception handling, which is a control abstraction as well. Conditional statements can be used to alter the flow of control in a program. So depending on which branch is taken, it'll go one path versus another. So you might have a conditional check, which will be true or false. And so it'll make a choice about which path to take. The if-else statement is the most popular way of doing conditional execution in Java. So you have if something or other, then do this, else something or other, do that. There's also something called a switch statement, which is basically a multi-way branch. So you switch on either an integral value like an integer or an enumerated type or even a string, and then there's a set of cases that are selected. This turns out to be a little bit tricky in languages like Java because they inherit all the quirks from languages like C of the semantics of a switch statement where you have to make sure you break if you don't want the cases to fall through, so it's a bit error prone. Not a lot of good reasons to use switch statements in object-oriented programming, but it's still there. Then there's also, of course, iteration. I'm sure you know what that is, so I won't spend much time on it. But basically, you can initialize a loop counter, and then you can iterate until some condition is false. And there are for loops and while loops and do while loops. You've probably got practice with for loops and while loops. Do while loops are not used quite as much because they execute the loop body at least once before checking the condition, but they exist as well. Typically, you use iteration in conjunction with conditional statements. So there's, again, hopefully nothing surprising there. Something that you may be a little bit less familiar with, and we'll use it quite a bit in this course, is exception handling, which is another form of control abstraction, if you think about what it's trying to do. It's basically giving you a way to separate out the normal path of execution from the anomalous path when something goes awry. And typically the way this works is if you are somewhere deep in a nested call stack and you discover something has gone wrong, rather than necessarily trying to handle it there locally, you might throw an exception. And that exception then, if it's not handled right away in a catch clause, will propagate up the call chain. As we see here in the slide, it goes up the call chain, and the JVM will check at each of the call sites to see whether there's an exception handler that knows how to handle that exception or some superclass of that exception. And at some point, hopefully, it'll be caught and handled properly. Now, if it goes all the way to the top, to the main thread, or to a thread, and there's no handler, then you'll get an unknown exception, and that typically causes your program to shut down. There are ways around that, but you typically will end up falling off the stack, and your program will exit. So that's kind of how exception handling works. You can think of an exception handler or exception mechanism as somewhat like a non-local go-to. It's going to go to a handler which may be up the execution stack in the Java runtime. And the reason for doing this is it makes it really, really, really hard to ignore things that go wrong. In languages like C, which lack exception handling, if something goes wrong, you're supposed to check the return value of a method call or a function and take some corrective action. Well, it's all too easy to forget to do that, and so errors can escape and not be caught. In languages like Java or C++, if used correctly, then it's a lot harder to ignore the errors because they're thrown as exceptions. Needless to say, exceptions should be used for exceptional conditions. Don't use them as a normal part of the processing because they have a fair amount of overhead associated with them. Let's give a couple quick examples in the context of our image counter app to illustrate some control constructs. So here is the, one of the main methods in the image counter app. And this is called count images. You give it a page URI, which is just a URL to either something on your local machine or out on the web somewhere. And it comes in and it checks to see whether or not we've exceeded the depth of recursion in our recursive structured hierarchy of pages. And if we have exceeded that, then we just return 0 because we're done. Otherwise, else if, it checks to see whether or not we've already visited this URI before. And if so, we ignore it. Otherwise, we go ahead and add the URI to our set of unique URIs, so we don't visit it again. And then we go ahead and call an implementation method that will count the number of images on the page. So that's just a simple example of if-else statements. So just a simple example here. Here is count images impl. This goes ahead and gets the start, the HTML for the page where we're starting. It goes ahead and figures out how many images were on that page, and then it goes ahead and recursively crawls any links accessible from that page, and it takes those two values, images in page and images in links that are on the page, which comes back as a list, because of course there could be multiple pages that are linked from that page. And then it goes into a for loop, and it counts up the number of images that are accessible on this page plus anything that is linked from that page. And this is what's called a for each loop. So it will iterate through every element in this list, and it'll basically count them and then return that. So that's a simple example of a control construct. As we'll discuss very shortly, nobody writes loops like this anymore in Java. That's so like 2010. And now we would write code that looked more like this. So this is using Java streams. So explicit looping and explicit external iteration is now deprecated in many ways. And so instead, we would use Java streams. And so what this does is this will get back a list of counts. We turn that into a stream. We do a little magic with a map method, which turns these things into integers, and we sum them up. So that's kind of how you would write modern Java 8 code. Yes, sir?
So that's actually more efficient than using a for each loop? Like, if you had both the options available, it's better to use this way?
Absolutely great question. So the question is, is this actually a win? So this is what the code looked like before, and this is what the code looks like now. If we just were doing this piece of code just exactly the way that I showed you here, it's probably about the same, right? In fact, this code might actually run a little bit faster because there's less machinery involved. However, this code here, and this is jumping a couple weeks down the road, this code here uses what's called the accumulator pattern, right? So what it does is it goes through here, and for each of these elements, it's going to accumulate the result in this variable images in page. Now, again, we've all written code like this, so it's not like the code is wrong. However, code based on the accumulator pattern requires a lot of extra work to make run in parallel. So this code, as I've written it here, is inherently sequential. Again, not the end of the world, but if we start running on a multi-core processor, this code is not going to be able to take advantage of that. In contrast, again, as we'll see shortly, this code, when we write it like this, becomes absolutely trivial to parallelize. And all we do is we simply change .stream, you see here, to .parallelstream. And boom, this code will suddenly be able to take advantage of multiple cores. So this is more of a divide and conquer-like strategy. So even if they're roughly the same, if they're run in the sequential model we show here, getting to write code like this is preferable because it makes it really easy to make it work in parallel. Now, whether you should run it in parallel or not is another story, and we'll come to that later. Was there another question? OK. So that's basically the end of the discussion about data and control abstractions. So let me shut that down for a second and